Hello, my name is Northcutt. I want to talk to you about a project I worked on called the Solar System Designer. This was a three-dimensional simulator built in Unity that allowed a user to design and create their own unique solar system, which applied actual physics and mimicked the real solar system. For this project, I was in particular in charge of creating the physics model, which proved to be a huge technical challenge for myself because I never developed a physics model or worked with one before, nor had I had any knowledge on astrophysics or celestial mechanics. And it was my first time working in the Unity development environment. So it was all new to me there, and I kind of want to walk you through some of the main issues with the project, with the model, and what I did to solve them. First was originally thinking that we would have more information from the user to develop the physics model, such as eccentricity, ellipse, and different focus points of the ellipse. And that way we could use the ellipse equation, or I could use the ellipse equation to calculate exactly what position the planet is at all times. But it turns out the user could only enter a mass and a distance. And with only two values, this just added a huge level of complexity to the project, especially with initial velocity, because I had to figure out now a way to calculate a velocity so that a planet gets captured by another planet's orbit. Another issue was the scaling of the project. Basically, the user can only enter in astronomical units and kilograms. Size of Earths for mass. And in physics, I calculate with kilograms and meters. And then Unity uses unity units. So there was three different types of scaled values which I had to work with and make sure everything was got scaled properly at all times, which added some level of complexity to the project as well. And being new to Unity, I never made a front end object move with back end code before, at least in a three-dimensional environment. So that was new to me. I'm trying to figure out how can I update the front end code of the graphics, the solar system, and move with my physics code. To solve this, first I did a lot of research, a lot of gravitational mechanics and physics equations and Kepler's laws, especially, which helped me develop an initial velocity equation with Kepler's third law. And basically, what that is the Kepler's third law with mass and distance. You can calculate how long it takes to go around one revolution, and you can break that down into seconds and figure out initial velocity. And then for scaling, I decided to strip all scaling values out of my gravity class and scale it elsewhere. That way, when I'm calculating all my force equations and all my physics equations, I don't have to worry about having the wrong units because they'll already be scaled before entering the class. For the front end and back end code connection, I did a lot of research in Unity's documentation, figured out what an update function is, and how to apply that to my classes and be able to translate that to front end code by connecting the script to the scene. And after implementing the changes, my results were fairly decent. I created an actual working physics model where you can enter a mass and distance and put two planets in, and they will orbit each other in accordance with the laws of physics. I did run into some issues, mainly with initial velocity. I had an initial velocity equation working at first, but it was only based on a planet-star interaction. It didn't account for moons with a planet because a planet has a greater pull on a moon, being that it's closer and slower. And the moon will orbit the planet, but instead my initial velocity is too high for that because it's measuring with the sun and shooting the planet off. So a little issue there, and then there were some scaling issues in the Unity side. The physics side, everything matched with actual physics, but the Unity side, if a planet was too close, you couldn't see it because the actual diameter of the sun or planet would cover that, and I didn't account for the diameter taking up Unity units. Um, but overall, the planets actually update around, so I was able to establish a good connection from front end to the back end code. If I could do it again, or what I would do next time, would be to do a lot more research in the physics area, get a better understanding of how the equations work and what is actually happening, and it probably would have saved me a lot of time there, and just catch risks and things that could have been prevented early. Also, it would have helped if I would have had time to do a lot more designing of the system itself. I did a lot of, here's some, here's a new physics equation, I'm going to implement it, bam. And I just ran with it, and then I had to backtrack, redesign the class. So if I had more time to design, make UML diagrams, it could have helped me, and it could have helped my team a lot better, improve the process. Also, a lot more testing would have helped. I've seen a few times where I found a solution to a problem and tested it once, saw it working, got excited, and moved on to the next thing without doing deeper tests and just a more formalized test process, which would have allowed me to catch more errors in the future, so I wouldn't have to later backtrack and fix issues that I should have caught earlier. And that was the project, and thank you very much.